All right, so in our last session, we really nailed down what our Hangman game needs to do. Today, things get real. Today, we become architects. We're going to move from just having an idea to creating the actual blueprint, the detailed plans that will guide our entire build. So let's dive in.
And hey, welcome back, software engineers. This is the core challenge, right? You've already done the hard work of figuring out the what. Now we've got to create the how, a really structured plan that turns that vision into something we can actually code.
So how do we actually bridge that gap? You've got this great idea, but how do you get to a piece of software that actually works? Well, the answer is all about documentation. We have to create the blueprints for our system before we write a single line of code. To do that, we need to get our heads around two really key concepts. On one side, you have to program logic. That's the how, the step-by-step instructions. We'll get to that later with flowcharts. But today, our focus is all on data architecture. This is the what and the where. So, if the logic is the engine of your car, then the data architecture is the plumbing. And for that, we're going to use two main tools, the data flow diagram and the data dictionary.
First up is the data flow diagram, or as you'll hear it called, the DFD. I want you to think of this as the high-level master plan for your entire system. It gives us that bird's-eye view, showing us exactly how information is going to move around inside our game.
So what is it really? A DFD is basically a map. It's a graphical model that does one thing and one thing only. It shows how data moves. It tracks the entire journey of a piece of information, from an input, like when a player makes a guess, all the way through different processes, into and out of storage, and finally back to the player as an output.
And here's the best part. You only need these 4 symbols to build the entire plan. These are the official NASA symbols, so you gotta know them. A rectangle is for an external entity. For us, that's our player. A circle is for a process, an action that actually changes the data, like check guess. A 3-sided rectangle is a data store. That's where we keep stuff, like our word list. And finally, you've got the labeled arrow, which shows the actual data flowing between all these parts.
Now, for our project, we are creating what's called a Level 1 DFD. See, a Level 0 diagram would just show the whole game as one big circle, which isn't super helpful. But a Level 1 diagram explodes that circle into all its key subprocesses. This gives us a much more detailed and honestly a much more useful view of how our game is really working under the hood.
And here's a perfect little walkthrough for our Hangman game. Step 1, the player, that's our external entity, gives us a player_guess. That data then flows to a check-guess process. That process, the circle, needs to check the guess against something, right? So it accesses the word list data store. Finally, the process creates a brand new piece of data, the game_state_display, and sends that back to the player. See? It's just the journey of the data.
Okay, now listen up, because this is the golden rule of DFDs. This diagram is only for data movement. We do not show decisions like if the letter is correct, or loops like while the player has lives left. All of that complex logic, that belongs in the flowchart, which we're going to build next week. So keep your DFD clean. Just focus on the flow.
Okay, so we've got our master plan. Now we need our second blueprints, and Nip builds directly on the DFD. If the DFD is the master plan, then the data dictionary is the super detailed materials list. It meticulously documents every single piece of data, every variable that our program is going to use. But before we can build that dictionary, we have to know our materials. Every piece of data in programming has a type. You've got integer for whole numbers like our score, string for text like the word we're guessing, Boolean for true or false states like, has the game been won, and floating point for decimals. We probably won't need that for Hangman, but it's a core type you need to know. Choosing the right type is absolutely vital.
And this is where the data dictionary comes in. It's the official document that defines all of this stuff. It acts as the single source of truth for every variable in our game. A table like this makes sure that anyone working on the project knows exactly what each piece of data is and how it should be used. And here's a perfect example of what this looks like for our game. Check out the variable score. We define its data type as integer, we describe its purpose, tracking the player's score, and we give an example, like 100. Or look at guess letters, which is a list of strings. This level of detail completely eliminates any confusion, and trust me, it makes the coding part so much easier later on.
So we know what these blueprints are and how to make them, but let's be really clear about why mastering them is so critical.
This isn't just busy work. This whole planning stage is directly tied to getting top marks in your assessment.
Let's start with the DFD, a clear, accurate, and what they call extensive diagram that's worth a full 5 marks in your assessment. That is a huge chunk of your grade for this section, and it's completely achievable if you just follow the steps.
So, how do you get those 5 marks? Simple. Here's your checklist for an extensive DFD. 1. Use the correct NISA symbols we just talked about. 2. Make sure you accurately map all the important data flows in your game. And 3, and this is a big one, you have to label every single arrow to show exactly what data is being moved. No exceptions. And guess what? The exact same thing applies to your data dictionary. There is another 5 marks on the table for a comprehensive, professional document. That means, together, these 2 blueprints make up a massive part of your overall grade for this stage. Now, to lock in those marks, your data dictionary needs to be exhaustive. Document every key variable. And crucially, you have to include all 8 of the required headings: data item, data type, format, size, and so on. Now, defining things like size in bytes might feel a little tedious, but that's what separates good engineers from great ones. It forces you to think about memory efficiency. Be specific, be professional, and leave absolutely zero room for guesswork. All right, you have the theory, you have the tools, the blueprints are ready to be drafted. Now it's your turn. It's time to start building the foundation of your project. It's time for groundbreaking. The learning muscle we're really flexing today is resourcefulness. This isn't about reinventing the wheel. It's about effectively using the established conventions and templates, the correct DFD symbols, the standard data dictionary headings, to design your system in a way that is clear and correct. It's all about using the right tool for the job.
And just remember the payoff here. All the effort you put in right now, carefully crafting these blueprints, is going to pay off big time when you start coding. A solid plan means a much smoother development phase, with fewer bugs and way less confusion. You are literally setting your future self up for success. So you have the tools, you have the knowledge, you are the architect. The only question left is, are you ready to draft the blueprints for your masterpiece?